Department of Mathematics, KSR College of Arts and Science for Women, Statistical Methods, Unit 4 and 5. Here we see the test of significance. Test of significance are statistical methods used to determine if there is evidence to support a hypothesis. They help researchers to make decisions about population parameters based on sample data. Two main categories are large sample test and small sample test. Key concepts used in this test of significance are sampling distribution, standard error, and test statistics. Now let us see the definition of sampling distribution and standard error. The sampling distribution is termed as the theoretical distribution of a statistics from any sample, whereas standard error is defined as the standard deviation of the sampling distribution. Formula for standard error of means is sigma by root n. The measure the variability of sample estimate is the importance of sampling distribution and standard error. Here next we see the large sample test in terms of means. It is used when sample size is large, that is typically n greater than 30. It is based on central limit theorem. Test statistics is based on z score. Formula z equal to x bar minus mu by sigma by root n. The assumptions are normal distributions or large sample size. Next we see the large sample test in case of difference of means. It is used for compare means of two population. Test statistics is z score. Formula z equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by sigma 1 square by n1 plus sigma 2 square by n2. It is useful for comparing treatments or groups. Next we see the small sample test, that is t distribution. It is used when sample size is small, that is n less than 30. It is based on t distribution. Degrees of freedom is n minus 1. Formula for t distribution is t equal to x bar minus mu by s by root n. The assumptions here are population is normally distribution. Next we see the F distribution for small sample test. It is used for comparing variances in ANOVA. Ratio of two chi-square distribution. Here the degrees of freedom is n1 minus 1 comma n2 minus 1. Formula F equal to s1 square divided by s2 square. It assumes populations are normally distribution. Next we see the chi-square test. It is used for categorical data. Two main types are goodness of fit and independence of variable. Goodness of fit compares observation between observed frequencies to expected. Independence of variable test a relationship between categorical variables. Formula chi square equal to summation observed frequency minus expected frequency the whole square divided by expected frequency. Next we see the goodness of fit. It is used if test sample data of its a specific distribution. Here the null hypothesis are observed frequencies matches expected frequencies. Steps calculated in goodness of fit are calculate expected frequency, calculate chi-square test statistics, then compare to critical value. It is used in quality control, election predictions, etc. Next we see the test of independence. It examines the relationship between two categorical variables. Null hypothesis, where it defines on variables are independent. Uses contingency table. Steps: create a contingency table, calculate expected frequencies, compute chi-square statistics, compare to critical value. Applications are market research, social sciences and medical studies. Thank you.